Okay, good day, everybody. Today's lab is going to be a packet tracer. In this chapter, we're dealing with port numbers. So this is my guide to what I'm going to do. We're going to ping IP addresses. So if we look at our topology, looks like the server has an IP of 192.168.1.254. And then the services running will be HTTP, HTTPS, DHCP, DNS, email, SMTP, POP, secure shell. So let's look at this PC, Rich. Looks like it has an IP. If we look at it, looks like it's static. So I'm going to check real quick and see if they're all static. Okay. And last one. Okay. So remember, we're going to look at the traffic. So we're going to go in simulation mode here. And it usually ends up being about this wide. The slider usually is here. So what I like to do is just kind of expand it. I need to see the type here. So if you need to adjust the column heads, just go in between and grab the line, and then you can move these around. So first thing we're going to do is see if we can have connectivity through ping. So I'll go to terminal. Let's do the IP config. IP config only gives us the active interface and the Bluetooth, which is not connected. If I do IP config /all, it'll give me all interfaces. So I have a fast Ethernet here, the Bluetooth. Here I have fast Ethernet, but I have more details. So you can see the details from here to here. So it depends on what you need. Either command will work. So let's ping 192.168.1.254. That is going to be the server right here. So I'm going to move the slide bar up just a couple notches. So when I hit play, let's reset. So I'm going to go back to command prompt and hit, I'll keep this on enter. All right. Now we can minimize the computer. So here's the packet, and it looks like if I click on it, I can see it starts at layer 3, source IP, destination IP, message type 8. Layer 2, so here's your 7 layers that we're going to be learning. So your corresponding layer 3, layer 2, layer 1. I'm going to let this play out. So it sent a message to everybody and said, who has this IP address? And so the server answers back, that's me. Okay, so let's take a look again. Doesn't get above layer 3, so we don't get to see port number. Look on the switch. We only go to layer 2, so that's important for later. We'll talk about layer 2 and switching. Once again, layer 2. We're all the way up here to layer 3 again. Now we're layer 2. Layer 2. I'm just going down the line to see. And you can see that time you see a switch, you're only going to see layer 2 information. Another switch, and then another switch. So we do not get to see port number with ICMP. So let's reset. Now I have to ping one more address because I need to make sure I can go to the switch. So I'm going to go back to the same computer, arrow up, and backspace and put a 3 in. Now that's going to be the switch. So when I hit enter, once again, we see up to layer 3, we don't get to see port number. So if I let it play out, once again, it goes into the switch, comes right back out because that's what we were pinging. So there's your ICMP. All right, let's reset. Now let's ping a domain name. This will go beyond layer 2 and push us up into the upper layers. I'm sorry, upper layers, upper than 3. So ping mihawk.org. Okay, so this has a different, it's no longer ICMP. So when I click on it, oh, so now we know that DNS is going to run through destination port 53. The source port is UDP, and it's using port number 1026, which is randomly assigned by the PC, or the NIC card, I should say. All right, so let's let this play out. Goes into the switch. The switch sends it to the server. So we're pinging the DNS. Okay, so what happened is we needed to get the IP address for mihawk.org, and so that's what these are doing. It's going to the server and saying, do you know the IP of mihawk.org? And so now we're back again to the ping, which we're not going to see port numbers. But when you see DNS, we do see port numbers. So this source, this would be source port random of 1026, destination port of 53. That's the well-known port number. Let's reset. Now let's go to a web browser and put in the IP address first and then the domain. So we'll see what the difference is. So back to same thing. I'm going to go to a web browser. So I got to get out of this screen. Click on the web browser. Now put in the IP of the server, which is 192.168.1.254. Press enter or go. Now here we have a TCP packet. Remember, source port is 1026. It's randomly picked by the NIC card, and destination port 80 is your well-known HTTP traffic. So if we let this play out, goes in the switch directs it to the server, server back to switch back to now. All this negotiation, all this process here was just to get to the HTTP. So this was all TCP. Now we're running HTTP. So remember, 1026 is random and port number 80 would be your HTTP traffic. So if we let that play out, if you haven't noticed, when you use TCP, it's really chatty and there's a lot of in-between conversations here. So once again, I'll pause. Let's look at the HTTP. Nothing should change. Now we're at a switch, so I won't see the port number. Once again, I get to see the port number here, port 80, HTTP. All right, reset. Now we're going to put in domain name this time. So mihawk.org. Now mihawk.org has an IP address behind it, and the server is the only one that knows. So if we go to the server real quick, let's take a look at where that's at. So services, DNS, right there. So if I don't have this configured properly, then the email doesn't work, and then the web browsing doesn't work, and a lot of other things do not work. So that's what we talk about when a network is layered. It's dependent on other layers to make things work. So once again, mihawk.org, we're going to go ahead and press enter or click OK or go. So once again, now we're DNS, so we should be able to anticipate that's port 53, random port number 1027. Let it play. Once again, we got to get the translation of the name of domain mihawk.org to the IP address. And then the traffic you want will start to happen. All right, so now we're back to TCP, port 80. So we're still web browsing. So if you look at we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, let's say negotiations to get the real traffic of your HTTP, which is your port 80 web traffic. So if I reset simulation, and if I just go back to the PC, you can see that it's actually pulling up the web page now. So we've done web browser, domain. So let's send an email. And if you see, let me go real time real quick. I have the port numbers listed up here for you. And also down here, this is something that I knew of, but I really never looked at it. So we should be using the secure SMTP, not just regular. All right, so let's go to simulation mode so we can see traffic. And okay, let's go to right here. I'm going to go to email. So close this, go down to email. And I'm going to compose one to Dylan. You can pick any user. All right, put in the username, put in hello, pay me. All right, so once again, we're going to hit send. And so if you read down here, it's saying sending mail to Dylan@mihawk.org with subject hello, mail server mihawk.org, resolving DNS. So now it's trying to get that. And so if we go to DNS again, if you forget, it's port 53. So we'll let this play out. Now we're trying to get email. So DNS is just a component of it to get the name translated to get back to be able to get the email server. So we're looking for some other protocol to pop. There it is, TCP. So I'm going to pause it, click on it. So your send receive email, which is SMTP, is port 25. Once again, we can start looking at the traffic, and it's not going to change other than, so from here, you see source is 2025, destination, but right here it flip-flops. So remember, you're originally the source, but when you get to the destination, that's new. The destination becomes a new source. Now you're the destination back. So this is where you kind of get a transition of port numbers here. So this source port now is 1028, but now it's flipped over so it can go back in transition. And 1028, which is assigned by the NIC, is random. So all that negotiation just to get the simple mail transfer to start working. So once again, port 25. And if I just do this, you can see I'm out of simulation mode and I wanted to see this message down here, the success. So that's the send receive. Now we got to do the POP, which is your post office box. So we got to go to Dylan. Okay, let's go to simulation. Go to Dylan. Now we need a check email. So let's do receive. Okay, now we have a DNS, port 53, but then this ARP. Interesting about the ARP, notice there's all F's here in the MAC address. It's a broadcast. It's saying I have an IP, I need a MAC address. So we'll talk about this later, but watch what happens to this message. Goes in the switch and then sent out all ports as a broadcast. The only one that responds is the device with the IP address. Now I have the MAC address, so I can go back to DNS. So we're trying to do mail POP. So we haven't even negotiated the mail traffic yet. So we're still waiting to see POP. Okay, there it is, I think. So let's click on this packet. 110 is POP. So look how many conversations we had to have, negotiations, to just get our mail traffic to say, can I see my new mail? And once again, we'll let the transaction occur. All right, so go back here. Now I'm going to go out of real time so I can see if the mail actually got received. And you can see the mail is successful. So you can look at the time and date, and then you can determine if it was sent today. All right, what's left? So we sent, received, now we got a SSH into the switch. So if you're new, we need to get out of the email and go to command prompt. So what we're trying to do is SSH into this switch. So this switch right here has got configuration on it. So we pinged it earlier. See, let's get to simulation mode. So the SSH in command prompt, it's SSH -L. That's not a 1, it's an L. That took me hours to figure out when I first started learning this. So the username is on the documentation of the topology. So it's admin, and then the IP address of the device, 192.168.1.253. I hit enter. So let's see what okay, I'll have to let that go away. So secure shell uses destination port 22. Once again, source port's randomized. Click on this, and now we don't see anything. So it's at layer 7. That's, you're like at the Outlook, you're at your email application. And here's our ARP, which is again, it says, hey, I know this IP. Do you know the MAC address? So you should see this one also go in the switch and then broadcast to everyone. And the only device that responds would be the one with that IP. So once again, the switch is the only one going to respond to that. All right, now let's see what's going on, because reset. So I got to put in password, cyber. See how I typed cyber and I had 3 sessions over there. So now you got to let it play out. Okay, so once again, if we're looking at this, 1026 was randomized. It doesn't change, and destination port 22 is your SSH. So you won't see those numbers change, except when they flip-flop, when the source becomes the destination then becomes a source. So you can see that these numbers won't change. And then if you want to see the success, all right, so I'm going to exit this and do it again. So arrow up. Simulation, you have to let it play out, and a lot of times it'll time out on you. So I'm just going to show you what it looks like. So remember, it's not going to type characters or symbols or asterisks for your password. Just type CYBER, enter. Now, if I do enable, and do cyber again, now we're into a switch, and we remoted into the device using secure shell, which means if they capture the traffic, they will not be able to decrypt it on the fly but we'll talk about that later also. But at least it's secure in transition. If they capture it, they have to do a lot of tricks to make that data readable. So once again, we're talking about port numbers in the layers. And so when you, if you remember, port layers are layer 4, and we should remember these today going forward. I hope you enjoy the rest of your day.